This is a formal example. It says show that v equals r omega based on the definition omega equals delta theta delta t of the angular speed. And I'm just going to look at this a little bit here because like maybe in a simpler way than the slide will wind up showing. But if I write down s is equal to r theta, and I've written it with a lot of space for some reason here. But if I write that formula down, the arc length formula, one way I could maybe look at this is I kind of said before that maybe you could argue that you could put deltas in front of both of these, one or both depending on the context. But if I'm thinking about this describing an object that is moving in a rotational sense, so it's rotating, right? And maybe in some amount of time it goes through a change in angle that's represented by delta theta, but I could also say, well, there's a corresponding, if the object has some radius and is in the shape perhaps of a circle or something like that, then it's also like going through a certain amount of arc length. And if I simply divide both sides, and again, I'm kind of taking a somewhat algebraic look at this, but I've kind of got some ideas in my head about what I think this is actually describing. But again, I can always do the algebra maneuver of dividing by a delta t on both sides. And then the argument that I have is that this really is the definition of omega. Omega is equal to delta theta delta t. So I simply replace that omega. And I'm reminded all of a sudden, I got to say at some point, this is not a W. So don't refer to it as a W. If you write it quickly, if I write it quickly, if anybody writes it quickly, it may look like a W, but you shouldn't refer to it as a W. It's the lowercase Greek letter omega. This delta S over delta T, though, I think that that's equal to V, which represents either a speed or a velocity in some context. It's an arc length per time, but really it is some distance over time. And if this were like a rolling object, it turns out that change in arc length would really correspond to the distance it rolled. And if you take that distance over time, that's the speed at which that object is rolling. So again, there's some interpretation depending on the application. But nevertheless, this formula pops out in a pretty straightforward way just by dividing again by delta t on both sides. And that's pretty much what this answer here in the slide did as well to get to this result.